determine the watts per square foot of each floor, it is essential to use the total ratings of the panels on each floor rather than relying on the amperage and voltage of the switchgear. The switchgear supplies power to the entire building, but its amperage and voltage do not directly reflect the power consumption of individual floors. The power and lighting panels on each floor are responsible for distributing power to the circuits and devices on that specific floor. Therefore, the total rating of these panels offers a more precise estimate of power consumption for each floor. To calculate the watts per square foot, firstly determine the total wattage for each floor by summing up the wattage ratings of all power and lighting panels on that floor. Secondly, divide the total wattage for each floor by the square footage of the floor. This calculation will give you the watts per square foot for each floor. It is important to note that this calculation assumes an even distribution of power across all floors. In reality, power consumption may vary based on occupancy and usage patterns on each floor. For a more accurate estimate, you may need to gather actual usage data or perform additional calculations considering the specific devices and appliances used on each floor. When assessing electrical systems, it's important to understand several key components and concepts. Let's delve deeper into how electrical systems work and how to accurately calculate power consumption. The electrical panel, often called a breaker box or load center, is a crucial component in the distribution of electricity throughout a building. It receives power from the utility company's service entrance and divides it into individual circuits, each protected by a circuit breaker. These breakers are designed to trip or disconnect the circuit if the current exceeds a safe level, preventing overloads and potential fire hazards. Within the electrical panel, each circuit breaker is rated for specific amperage, which indicates the maximum amount of current that the circuit can handle safely. Common breaker ratings include 15 amps, 20 amps, 30 amps, and higher, depending on the intended use of the circuit. For example, a typical lighting circuit might be protected by a 15-amp breaker, while a circuit serving a large appliance like an air conditioner or an electric stove could require a 30-amp or higher breaker. The total capacity of the electrical panel is determined by the main breaker, which is typically rated for a higher amperage than the individual branch circuit breakers. This main breaker protects the entire panel from overload and ensures that the total demand on the system does not exceed its capacity. Understanding the ratings and functions of circuit breakers is essential for electrical safety and proper system operation. Now, let's consider the different types of electrical loads that you might find in an office building. Electrical loads can be broadly classified into two categories: resistive loads and reactive loads. Resistive loads are those that convert electrical energy directly into heat, light, or other forms of energy without storing any significant amount of energy in magnetic or electric fields. Examples of resistive loads include incandescent light bulbs, electric heaters, and toasters. The current and voltage in a resistive circuit are in phase, meaning that they reach their maximum and minimum values at the same time. Reactive loads, on the other hand, are those that store energy in magnetic or electric fields. These loads include motors, transformers, and fluorescent lighting fixtures. Reactive loads cause the current and voltage to be out of phase, which could affect the power factor of the electrical system. The power factor is a measure of how effectively electrical power is being used. A power factor of 1 indicates that all of the power being supplied is being used to perform useful work, while a power factor less than 1 indicates that some of the power is being wasted due to the reactive nature of the load. Utility companies often charge businesses for low power factors, as it constrains the electrical grid and reduce efficiency. To improve the power factor, businesses can install power factor correction equipment, such as capacitors, which counteract the effects of reactive loads. Understanding the types of electrical loads and their impact on power factor is crucial for optimizing energy efficiency and reducing costs. To calculate the total power consumption of an electrical system, you need to consider the voltage, current, and power factor. The basic formula for calculating power in a direct current or DC circuit is power equals voltage times current, where power is measured in watts, voltage is measured in volts, and current is measured in amps. However, In an alternating current, or AC, circuit, the power factor must also be taken into account. The formula for calculating power in an AC circuit is power equals voltage times current times power factor. For example, if a circuit has a voltage of 120 volts, a current of 10 amps, at a power factor of 0.8, the power consumption would be 120 volts times 10 amps times 0.8, which equals 960 watts. It's important to note that the power factor can vary depending on the type of load and the operating conditions. To accurately measure the power factor, you can use a power analyzer or a multimeter with power factor measurement capabilities. Now, let's discuss the importance of accurate electrical measurements in calculating watts per square foot. To determine the watts per square foot for each floor of an office building, you need to accurately measure the power consumption of each floor. This can be done by using a power meter or a data logger to record the current and voltage of the electrical panels on each floor over a period of time. The data can then be used to calculate the power consumption and determine the watts per square foot. It's important to take measurements over a representative period of time to account for variations in occupancy and usage patterns. For example, you might want to take measurements during peak hours, off-peak hours, and weekends to get a comprehensive picture of power consumption. Additionally, it's important to calibrate your measuring equipment regularly to ensure accuracy. Inaccurate measurements can lead to incorrect calculations and potentially costly mistakes. When taking electrical measurements, always follow proper safety procedures to avoid electrical shock and other hazards. Wear appropriate personal protective equipment such as insulated gloves and safety glasses, and energize circuits whenever possible before working on them. If you are not comfortable taking electrical measurements yourself, it's best to hire a qualified electrician to do the work. In addition to measuring power consumption, it's also important to consider the electrical codes and standards that govern the design, installation, and operation of electrical systems. The National Electrical Code, or NEC, is a widely adopted set of standards for electrical safety in the United States. The NEC provides guidelines for wiring methods, overcurrent protection, grounding, and other aspects of electrical systems. Compliance with the NEC is essential for ensuring the safety of building occupants and preventing electrical hazards. State and local jurisdictions may also have their own electrical codes and regulations which must be followed in addition to the NEC. It's important to stay up to date on the latest electrical codes and standards to ensure that your electrical systems are safe and compliant. The NEC provides tables such as 310.15b16, which covers allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current carrying conductors in raceway, cable, or earth directly buried based on ambient temperature of 30 degrees Celsius. This table is important for selecting the appropriate size conductors for electrical circuits to prevent overheating and potential fire hazards. This table lists the ampacity of different sizes and types of conductors based on their insulation temperature rating and the ambient temperature. The ampacity of a conductor is the maximum amount of current that it can carry safely without exceeding its temperature rating. When selecting conductors for an electrical circuit, it's important to choose a size that has an ampacity greater than or equal to the calculated load current. It's also important to consider the derating factors that may apply due to ambient temperature, conductor bundling, or other conditions. Failure to properly size conductors can lead to overheating, insulation damage, and potentially fire hazards. Grounding is another critical aspect of electrical safety. A grounding system provides a low impedance path for fault current to flow back to the source, allowing overcurrent protective devices to trip and clear the fault. A properly grounded electrical system helps to prevent electrical shock and reduce the risk of equipment damage. The NEC requires that all electrical systems be grounded in accordance with specific requirements. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel and other equipment. The grounding electrode provides a connection to the earth, which helps to stabilize the voltage and provide a path for fault current. Bonding is another important aspect of grounding. Bonding refers to the practice of connecting all metal parts of an electrical system together to create a common ground potential. Bonding helps to prevent voltage differences between metal parts, which can create a shock hazard. The NEC requires that all metal parts of an electrical system, such as metal conduit, metal enclosures, and metal equipment, be bonded together. Surge protection is also an important consideration for electrical systems, especially in areas that are prone to lightning strikes or power surges. Surge protective devices, or SPDs, are designed to protect electrical equipment from voltage spikes caused by lightning, utility switching, or other sources. SPD work by diverting the excess voltage to ground, preventing it from damaging sensitive electronic equipment. The NEC requires that SPD be installed in certain locations, such as service entrances and electrical panels. SPD are available in a variety of types and sizes, depending on the application. When selecting SPD, it's important to consider the voltage rating, surge current capacity, and other specifications. In addition to the technical aspects of electrical systems, it's also important to consider the economic aspects. Energy efficiency is a key concern for businesses looking to reduce their operating costs and minimize their environmental impact. There are many ways to improve the energy efficiency of an electrical system, such as using energy-efficient lighting, installing occupancy sensors, and optimizing the operation of HVAC systems. Energy-efficient lighting can significantly reduce power consumption, especially in large office buildings. LED lighting is a popular choice for energy-efficient lighting, as it consumes significantly less power than incandescent or fluorescent lighting. Occupancy sensors can automatically turn off lights in unoccupied areas, saving energy and reducing costs. Optimizing the operation of HVAC systems can also save energy. This can be done by using programmable thermostats, scheduling equipment operation, and performing regular maintenance. By implementing energy-efficient measures, businesses can significantly reduce their energy consumption and save money on their utility bills. Regular maintenance is essential for ensuring the safe and efficient operation of electrical systems. Electrical equipment should be inspected regularly for signs of wear, damage, or corrosion. Loose connections should be tightened, and damaged components should be replaced. Regular maintenance can help to prevent electrical hazards and extend the lifespan of electrical equipment. It's also important to keep electrical panels and equipment rooms clean and free of obstructions. This will help to ensure that the equipment can operate properly and that technicians can access it easily for maintenance and repairs. In conclusion, calculating watts per square foot for each floor of an office building requires a thorough understanding of electrical systems, accurate measurements, and adherence to electrical codes and standards. By following the steps outlined above and implementing energy-efficient measures, businesses can ensure the safe and efficient operation of their electrical systems and reduce their energy costs. Remember to prioritize safety when working with electrical systems and consult with qualified professionals when needed. Understanding the building's electrical system involves knowing the location of the main disconnect, the distribution panels, and the emergency power systems. The main disconnect allows for the entire building's power to be shut off in case of an emergency or for maintenance. Distribution panels, located throughout the building, further divide the power into smaller circuits for lighting, outlets, and equipment. Emergency power systems, such as generators or battery backup systems, provide power during outages to critical systems like fire alarms, emergency lighting, and life support equipment. A single-line diagram of the electrical system provides a visual representation of the power distribution from the utility source to the various loads within the building. It shows the location of transformers, switchgear, panels, and major equipment along with their ratings and interconnections. This diagram is essential for understanding the overall system layout and troubleshooting issues. Reviewing the building's electrical drawings and specifications provides detailed information about the wiring, conduit, and equipment used throughout the building. These documents include floor plans showing the location of outlets, lighting fixtures, and electrical panels, as well as detailed schematics of the electrical circuits. Understanding these drawings is crucial for identifying potential problems and planning for future modifications. Understanding the electrical system's design, components, and documentation is essential for determining the watts per square foot and ensuring safe and efficient operation.